introduction. In this project, we're going to discuss about photodiode, LED and laser diode. Before we looking forward about electronic components, we should know about electric circuit, which is include a device that giving energy to the charged particles that consume the current. Basically, we should have knowledge about electronic device. Electronic devices are small devices or a group of small devices designed to control the flow of electrical circuit for their using in different applications. The main purpose of electrical components include motion control and information processing. There are two types of electronic devices such as active and passive. The active component generally supply energy and these components depend on the external power to function. Example devices are diode, integrate and circuit. The passive component in electronic can only absorb the energy in the electric. The passive components are such as resistor, capacitor and inductor. As we can know about photodiode, LED and laser diode are active components. Photodiode, which is a discharging type of PN junction, connect to the instrument that create current when unprotected to light, is a famous photodiode. It is also known as photodetector or photosensor. It is back partial way and convert light straight into energy straight. Secondly, the LED stands for light emitting diodes, which is semiconductor device that emit light when current flow toward it. Lastly, laser diode. It is a semiconductor device similar to LED in which is a diode pumped direct with the electrical current can create lasing condition at the diode junction.
Firstly, I would present about what is a diode. A diode is a semiconductor or device that existently acts as a one-way switch current. It allows current to flow easily in one direction but severely restrict current from following in the opposite direction. Diode have polarity determined by an anode positive plate and cathode negative plate. Most diodes allow current to flow only when positive voltage is applied to the anode. Secondly, how diode is work. Diode have two terminals, anode and cathode. Whether current flow or not depends on the direction of voltage applied to these terminals. This operation is called rectification and is the basic operation of diodes. Current can flow from anode to cathode that called forward bias. Otherwise, current cannot flow from cathode to anode that called reverse bias. Semiconductors are divided into P-type semiconductors and N-type semiconductor based on the difference in the electricity flow mechanism. P-type semiconductors are those in which electrons move in sequence fill in the missing holes. Relevant elements such as silicon mixed with a relevant additive like boron or gallium become P-type semiconductor. A P-type semiconductor has more holes than electrons which allow the current to flow from hole to hole. Because it lacks on electrons, it is considered positively charged. N-type semiconductors carry electricity with fewer free electrons than metal bonds. Relevant elements such as silicon mixed with a pentavalent additive like phosphorus become N-type semiconductors as they provide more electrons to the structure. Thirdly, we see usage of diode. Diodes are used in variety of applications. By removing the signal component, several of them convert current AC to DC current. They are known as rectifiers when used in position. They act as electric switches and can block voltage spike, making them ideal for surgical protectors. They are high to do digital logic. Power supply and voltage doubles are also made with it. The sensors as well as light on lighting devices, lasers really on LEDs.
What is LED? LED are a type of semiconductor called light-emitting diode. White LEDs, which have achieved practical realization through the use of high-brightness blue LEDs developed in 1993 based on gallium nitride, are attracting increased attention as a fourth type of light source. Okay, how LED work? The LED is a specialized form of PN junction that use a compound junction. The semiconductor material used for the junction must be a compound semiconductor. The commonly used semiconductor or material, including silicon and germanium, are simple element, and junction made from this material do not emit lights. Instead, compound semiconductors including gallium arsenide, gallium phosphide, and indium phosphide are compound semiconductors, and junctions made from these materials do emit lights. These compound semiconductors are classified by valence bands their constituent occupy. For gallium arsenide, gallium has a valency of 3 and arsenide a valency of 5, and this is what is termed a group 3V semiconductor, and there are a number of other conductors that fit this category. It is also possible to have semiconductors that are formed from group 3V materials. The light emitting diode emits lights when it is forward biased. When a voltage is applied across the junction to make it forward bias, current flow as in the case of PN junction. Holes from P-type region and electron the N-type region enter the junction and recombine like a normal diode to enable the current to flow. When this occurs, energy is realized, some of which is in the form of light protons. It is found that the majority of light is produced from the area of the junction nearer to the P-type region. As a result, the design of the diode is made such that this area is kept as close to the surface of the device as possible to ensure that the minimum amount of light is absorbed in the structure. To produce light which can be seen, the junction must be optimized and the correct material must be chosen. Pure gallium arsenide realizes the energy in the infrared portion of the spectrum. To bring the light emission into the visible red end of the spectral, aluminium is added to the semiconductor to give aluminium gallium arsenide. Phosphorus can also be added to give red light. For other colors, other material are used. For example, gallium phosphide give green light, and aluminium indium gallium phosphide is used for yellow and orange light. Most LEDs are based on gallium semiconductors.
What is photodiode? A photodiode is a PN junction diode that consumes light energy to produce an electric current. They are also called a photodetector, a light detector, and a photosensor. Photodiodes are designed to work in reverse bias condition. Typically, photodiode materials are silicon, germanium, and indium gallium arsenide. How a photodiode works? A photodiode is subjected to photon in the form of light which affect the generation of electron pairs. If the energy of the falling photon is greater than the energy gap of semiconductor material, electron-hole pairs are created near the depletion region of the diode. The electron-hole pairs created are separated from each other before recombining due to electron field of the junction. The direction of the electric field in the diode forces the electron to move toward the N side, and consequently, the holes move toward the P side as a result of the increasing in the number of electrons on the N side and holes on the P side, and rise in the electromotive force in observed. Now, when an external load is connected to the system, a current flow is observed through it. The more the electromotive force created, the greater the current flow. The magnitude of the electromotive force created depends directly upon the intensity of the incident light. This effect of the proportional change in photocurrent with the change in light intensity can be easily observed by applying a reverse bias. Since photodiodes generate current flow directly depending upon the light intensity received, they can be used as photodetector to detect optical signals. Built-in lenses and optical filters may be used to enhance the power and productivity of the photodiode. Difference between LED and photodiode. The LED operates on the principle of electroluminance, while photodiode works on the principle of the photoconduction. In a light-emitting diode, when electrons and holes recombine, the energy is released in the form of light. Thus, it is termed as light-emitting diode. On the contrary, photodiode generates current when it is exposed to the source of light. LED and photodiode are reverse of each other. LED generates light with the help of charge carrier, while photodiode generate current due to incident photons. In a nutshell, LED converts the electric energy into light energy, but photodiodes converts light energy into electric energy.
Laser diode. A laser diode is a semiconductor that uses a PN junction for producing coherent radiation with the same frequency and phase, which is either in the visible or infrared spectrum. It is also called an injection laser diode, and the technology is similar to that found in LED. How it is worked? When DC voltage is applied across the laser diode, the free electrons move across the junction region from the N-type material to the P-type material. In this process, some electron will directly interact with the valence electrons and exits them to the higher energy level, whereas some other electron will recombine with the holes in the P-type semiconductor and release energy in the form of light. This process of emission is called spontaneous emission. The photons generated due to spontaneous emission will travel through the junction region and stimulate the exit electrons. As a result, more photons are released. This process of light or photons emission is called stimulated emissions. The light generated due to stimulated emission will move parallel to the junction. The two ends of the laser diode structure are optically reflective. One end is fully reflective, whereas another end is partially reflective. The fully reflective end will reflect the light completely, whereas the partially reflective end will reflect most part of the light but lose a small amount of light. The light generated in the PN junction will bounce back and forth hundreds of times between the two reflective surfaces. As a result, an enormous optical gain is achieved. The light generated due to the stimulated emission is escaped through the partially reflective end of the laser diode to produce a narrow beam laser light. All the photons generated due to the stimulated emission will travel in the same direction. Therefore, this light will travel to long distance without spreading in the space.
Conclusion. In conclusion, we can know about the advantage of using electronic devices such as easy access to information, encouraging innovation and creativity. Digital technology has transformed our world we are living in. Our life has really transformed because of all the gadgets we are surrounded by, from the phone to the fridge in your kitchen. In this project, we have learned about the function of photodiode, LED, laser diode, and material inside the electronic components, the inventor of this component, and lastly, we recognize all the important and difference between components that can help circuit and system to flow current. Thank you.